In these videos, we'll talk a little bit about radical functions, not to be confused with rational. And yes, they are very radical. They're very cool little things, not as commonly used, but important to know just a little bit about. So a radical function is a function whose variable or variables is a radicand, i.e. is under a radical. So let me give you an example. Y equals the square root of x would be considered a radical function. Y equals the square root of x squared plus 7 is a radical function because its variable is a radicand, meaning that it's underneath the square root sign. So let's suppose that we have an above ground pool and it springs a leak. The amount of water that has been removed from the pool in gallons is a function of time. So we'll just use y and x. So we'll just say y is the amount in gallons, x is the time in minutes, and let's say that that model is y equals 100 times the square root of x. Well, what does that mean? Well, that means that we basically would be able to determine the amount of water that's been leaked out depending on how much time has passed. So let's just take a look at what this would look like. So we know that a square root means what number times itself gives me the number under the radical. So square root of 4 is 2, square root of 9 is 3 because 3 times 3 equals 9, square root of 16 is 4 because 4 times 4 is equal to 16. And we know that we can't take square roots of negative numbers, right, because that says there's no real answer to that. In other words, what number times itself is negative 16? Well, 4 times 4 is positive 16. Negative 4 times negative 4 is positive 16. And you can't combine a positive and a negative because those aren't the same number. So it's what number times itself. So let's just look at some values of x. So I'll start at x equals 0. So I have 100 times the square root of 0. Well, 0 times 0 is 0, so that's the square root of 0. 100 times 0 is 0. When x is 1, that means that 100 times the square root of 1, the square root of 1 is 1. 100 times 1 is 100. So that means by 1 minute later, 100 gallons of water have leaked out of this pool. So we're just, obviously it's a pretty big leak, right? And by the second minute, well, now that's going to say we have to take 100 times the square root of 2. Well, what's the square root of 2? Well, the square root of 2, if we go to our calculator and we multiply it by 100, so 100 times whatever the square root of 2 is about 141.42. So you notice that over the next minute, the number of gallons, and I'll just round this to the nearest whole number, so I'll just say 141 just about. So we notice that only 41 gallons have leaked out, whereas over the first minute, more has leaked out. Well, you can probably justify this by saying, okay, well, there's gravity, and if you have a leak in here, then initially, since there's more pressure, water will probably exit at a faster rate. And eventually, that rate will become a little bit slower, so less water will leak out. Now, over the third minute, we would take 100 times the square root of 3. So we take 100 times the square root of 3, giving us 173. So again, we've had a decrease in the rate of change. So if we plotted these points, if we looked at x against y, we would notice that 0, 0 is a point on the graph, 1, and then way up here, let's say that's 100, and then 2 and 141, so it's it's somewhere about here, and then 3 would be 173, so that increases less again. And we notice we kind of have this type of shape to the graph, which is something we haven't quite experienced in past functions. And so essentially what's happening is the change or the rate of change is decreasing. Now we would notice that if you looked at the change in the rate of change, it's not as simple as it's not as pretty as a quadratic function. The rate of change decreased by 59 from 0 to 1, from 1 to 2, or from this rate of change to this rate of change, it only decreased by 9, excuse me. So the change in the rate of change isn't constant either. It's gradually kind of flattening out. Now, will it ever come back down? No, it won't, because there's no number that we can take the square root of that's going to, when you multiply it by 100, in fact, make it smaller. So this, by definition, is a radical function. We could graph this function by putting into our calculator 100 times the square root of x. And for now, we're just going to do zoom standard, just so that we can see it. And oh, I guess we need to go a little bit higher because we go all the way up to 100.